if they intersect, is it just one point or infinite number of points? Can the straight line just meet at just 2 points? It is never possible. It can either meet at just 1 point, or they can overlap and meet at infinite number of points. Okay, so the case of the in-between case is not possible. Two lines can never meet at 2 points or 3 points, exactly 2 points or 3 points. They will either meet at just 1 point or meet at infinitely number of points. That means they will overlap each other. Okay, or they can never meet because the lines are parallel. So we have 3 cases. Okay, so we'll discuss these cases one by one. The first case is intersect at 1 point. If these two lines intersect at 1 point, the condition is that A1 upon A2 is not equal to B1 upon B2. Okay, and if they intersect at all the points, that means if they coincide, if two straight lines coincide, in that case these two straight lines will represent just one straight line. Okay, so this straight line is equivalent to this straight line. What will happen is, if this equation is, let's say, x plus y plus 1 is equal to 0, the other equation might be 2x plus 2y plus 2 is equal to 0. So only the factor of 2 is coming in common, and this equation will become this equation only. Okay, so this will mean A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. Right? So this is the condition for coinciding lines. Okay. Third condition is the condition for parallel lines. Okay. The condition of parallel lines will be that the slopes will be same. So if the slopes are same, that will mean that slopes are defined by these two coefficients. Okay, coefficient of x and coefficient of y. That will mean that A1 upon A2 is equal to B1 upon B2, but this is not equal to C1 upon C2, because if it is equal to C1 upon C2, this will become the same straight line. Okay, the two lines will coincide, but the two lines are not coinciding. What actually is happening is these two lines are parallel. In this case, A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2. So these are the 3 methods how to find whether the lines are intersecting at just 1 point, coinciding, or they are parallel lines. Okay, in this case, intersecting at 1 point, we have a solution. Okay, so we have a unique solution, right? And in this case, we have infinite solutions, right? But in this case, since these two lines are parallel, they will never intersect. So in this case, we have no solution, right? So we can divide these two parts, and we can generalize that. We can generalize that this is a condition for consistent equations. Consistent equations means because they have a solution. Okay, they have an answer. They intersect at some point. So these two lines are consistent, while these two lines are non-consistent. Okay, so these are two cases of consistent equations, and this is the one case of non-consistent equation, because these are two parallel lines and